Hello and welcome to this video. This is all part of a series of videos where we're showing you the setup and the run-in of the NC4 laser tool setter. Today we're going to be measuring bore nose cutters and cutters with corner radius. So I'll welcome back the expert of the NC4. Hello again, Ian.
Hello, thank you.
So what cycle are we running today and what can it do?
So today we're running cycle 9867, which gives us the ability to measure the corner radius of the tool, as well as the tool's length and diameter.
So as I remember, this cycle is slightly different to our other measurement cycle, which is the 9862 cycle. Here, the B input is related to our tool shape. So a B1 is for bore nose cutters, and B2 is for end mills or slot drills, but with a corner radius.
Yes, that's correct. So with B1, we are going to measure the tool length and corner radius. We're going to update the tool length offset, and then we're going to take the measured corner radius. We're going to times it by 2, because this machine uses a diameter offset style, and then we're going to update the diameter offset. With the B2 shape, we're going to measure the tool length, the tool diameter, and the corner radius. We're going to update the tool length offset, the tool diameter offset, and we're going to store the corner radius in #102.
With this 9867 cycle, we can measure bore nose cutters, we can measure cutters with corner radius, but what about barrel mill cutters?
Unfortunately not. Barrel mill cutters use segments of very large radii. With cycle 9867, we need a full 90-degree arc.
Okay, thanks for clarifying that, Ian. So on the machine today, we have a NC4 Blue. It's an F145, and we would like to measure a 10mm bore nose and a 16mm end mill with a 4mm rad. So let's start with the 10mm bore nose first. Over to you, Ian.
So first we want to put into the name of the cycle, so G65P9867. Then we want to enter B1, which tells the cycle this is a bore nose cutter. C5 is the nominal corner radius. F3 is the amount of measurement points we want to take on the corner radius, 3 in this case. And R10 is the nominal diameter of the tool. And that's all we need.
We've successfully measured the 10mm bore nose. So where are these measurement results stored?
Like I mentioned previously, with the B1 input, both the length and the diameter are written into the tool offset. The calculated corner radius is multiplied by 2 in this case, because on this machine the tool offset is stored in diameter.
Okay, so the measured radius is used then to update the tool register, understood. So is there anything else our viewers need to consider when using the B1 input?
2 things come to mind. Be mindful of the F input, as that dictates how many measured points we'll make on the arc. And unless you're looking to measure the full arc in many places, typically F1, F2 or F3 are the correct number of inputs to use. And secondly, if you're measuring a tool where the ball is almost full form, like a button tool, you must enter the Z input, and that ensures that the initial diameter measurement takes place at the equator of the button.
Okay, thanks for that, Ian. Right, so let's move on to our second tool, which is the 16mm diameter cutter with a 4mm radius. So again, over to you, Ian.
First we want to enter the cycle name, which is G65P9867. Then we want to enter B2, which tells the cycle this is an end mill with corner radius. C4 is the nominal corner radius. F3 is the quantity of measurements we want to make on the corner radius. R16 is the nominal diameter of the tool. And in this case, we want to enter a tolerance for the corner radius, and I've entered 0.2 millimeters.
Okay, the cycle's finished, all seems successful, but as you mentioned earlier, this type of tool, the results are stored slightly differently.
Well, with the B2 input, the tool length and diameter are written to the tool offset as normal, but we also store the corner radius in #102 for reference.
Okay, thanks Ian. And finally, we've gone through all the main cycle inputs today, but I guess there are other inputs like spindle speed, tolerance check-in, all of which are in our programming guide.
Yes, we've gone through the basic inputs today, the ones that are most commonly used. In our programming guides, we have an extensive list of inputs, so the viewers can always refer to those if they want to do more with the cycle.
Thank you again, Ian. So that was a 9867 cycle. Thank you for watching. If you've enjoyed this video, please remember to like and subscribe. Happy tool setting.